Okay,
Thank
go
you
ahead.
very much. So today, thank you very much for being here. Today I would like to talk a little bit about Siemens Health in years. So I was asked several times what is health in years. So around 3 years ago, we had the same journey as Siemens Energy. So we have been spin off and we are at the stock market by our own. And it's a combination of healthcare, pioneer, and engineering. So let me start with a short agenda. So at the beginning, I would like to introduce what Siemens Health in years is, and also show you where the digitalization is going in the medtech market. And in the second half, of course, I would like to mention about our new greenfield plant. It's called High Energy Photonic Center. It's a new site for around 800 people close to Erlangen in Germany, where we manufacture medical equipment. On the right side, you see a typical instrument we are manufacturing. So at the back, you see a computer tomography system where you can detect very quickly a 3D model of your body. It takes around 10 seconds till your body is scanned. And in the gantry, there is the X-ray tube rotating around the patient with around 4 rotations per second with 240 kilowatts of power and around 1 ton in weight. It's really creating a 3D model, but not a real-time imaging. And the system in the front, you see it's a real-time imaging system for X-ray. If you're becoming a surgery, for example, after a heart attack, you are lying on this table, and then the medical staff is getting a real-time image with 60 frames per second in a 4K resolution. And what we are doing here is combining the two systems, the 3D model from the CT combined with a real-time application during the invention. So I'm clicking. Okay, so what is Siemens Health in years? So very quickly, so you see here on the left top, adding a number. So a few months ago, we did an acquisition. We bought Varian in the US. That was the market leader in radiation therapy for cancer treatment. And currently, we are around 67,000 people. And in the middle, you see more than 90% of the leading hospitals are collaborating with us in China, Germany, and the US. And on the right bottom, you see we have around 600,000 instruments installed worldwide. Around 240,000 examinations are done every hour with our instruments. And around 70% of the clinical decisions is done with our instruments. And of course, on the right top, you see there are some AI-supported applications, which you will also see one application later on for radiation therapy planning. What do we think, where will healthcare be? So we think that the medicine will become more precise. You are not a standard person, you are not a standard patient, you are an individual, and also the medicine has to become your individual medicine. And also the value will increase. So I think the most of you know better the status of your car than of your body. And this is what we want to offer, a service where you get your checkup every day. Then the patients will become consumers. So you want to know actively what is the status of my body, what do I have to do next to live long. And at the end, of course, the healthcare will become digital. You can see on the right side a link to my LinkedIn profile. You can go there. We have made a video of the vision, how the healthcare will look like in future. So why do we need digitalization in healthcare? So the population will grow, like the energy demand we heard this morning. So the goal will be in 2050, it will be close to 10 billion people worldwide, and the most people will grow in the developing countries and emerging countries. And therefore, we need affordable entry-level healthcare, but also very precise medical care. And therefore, we are working on the digitalization. This is the value chain we are looking at. So on the left, you see lots of data. Yeah, the data are coming from from all kind of instruments, from my Apple Watch. So the Apple Watch mentioned that I'm very nervous. So when I was coming before, he said, "Oh, your heart rate is going up." What happens? So all this data, then of course the data from our machines, from when you go to your doctor, when you make a blood analysis, all this data will be collected together, and then there will be data-driven decisions. And on the right, you see then we connect the care teams worldwide with our systems, but also with the patient, because he wants to know what's happening with me, what is going on with me. And of course, on the right, self-learning systems, which is going up. Here you see one of our computer centers. It's close to in Princeton, in the US. So if it would be an official computer center, it would be among the top 10 computers in the world with 24 petaflops. We are storing there around 1 billion medical images, and we are performing around 600 AI experiments a day. This does also mean continuous learning. And here you see, for example, an application for the AI. If you have cancer in your body and you need a radiation therapy, so this means a high-energy photon is killing the cancer cells in your body, you have to take care that this beam is not hitting other tissue. And therefore, a CT scan is done before, and then the medical staff has to plan the treatment, and this is done currently with our new IA application. You see here 71 organs are detected automatically, and this algorithm is trained with 5 million data sets, and helps, of course, for the doctor to really plan the treatment. So, and this is a kind of vision. In the middle, you see the head of our AI group in Princeton. It's Dorian Kumaniciu, and so he took pictures, MR pictures of his brain on the left top. On the right bottom, you see the heart, and this is, in principle, the digital twin we want to create for every individual person. And with every scan or exam, this model is updated and used for planning the invention. On the right, we have the first models for if you are getting a heart attack, for example, and you come to hospital, the medical staff can simulate the invention. So what happens if I open this vessel or if I close this vessel? Is this done correctly? You can also adjust the chemicals or the medical invention which is done with simulating your heart before really doing the surgery. Okay, so this was a little bit about what we think the digital twins will look like. And of course, our products also have to offer digital twins. And how do we do this? So on the top, you see, of course, the normal product life cycle. It goes from the customer requirements through the R&D department to manufacturing, to the installation. And we mirror this whole process to 3 digital twins. It's the digital twin of the product. In the R&D, it's the digital twin of the production, which I will tell you later about our new site, and the digital twin of operation, the performance twin or digital shadow. And all this thing is done in an agile development, and the whole Healthineers team is working in one digital backbone for R&D and SCM. So, and now I would like to come to the second part of the talk. What is the High Energy Photonic Center? This is the building we've currently constructed in Erlangen or in Forchheim. On the left, you see where we are coming from. So we have 2 sites currently in Erlangen, where we manufacture the X-ray tubes and the high voltage generators. And all these 2 locations are brought together to one side. On the right, you see the digital twin of the building currently, which is completely done in a digital way. So we plan it. It's called BIM at the beginning, Building Information Management, all in our digital backbone. The factory will be lean and flexible. And of course, as we heard this morning, we want to enforce the cooperation between the different functions. And of course, a little bit sustainable, as we heard this morning. What you can also see in the movie is this is just a kind of IKEA planning of your manufacturing site, but what comes now is really the virtual commissioning of the machines. So here it's a robot-assisted cooperation, so you can simulate the cycle times, the processes, is there any issues, but also you can simulate the movement of the worker. This is important for the worker council that the workers are doing their job in a safe way. So we started our digital transformation around 3 years ago, and then there came this great opportunity that we can really construct a new site. And we created a smart factory vision for us. And how did we do this? So we made, of course, as you had it several times already, a value stream analysis and a use case elaboration. And in this elaboration, for us, it was really a very good chance to also use this 10x thinking, from Elon Musk, for example, if you know his book. So really think far beyond and then go back to your manufacturing, what you want to do. And then we created on the right side a scribble, like from Siemens Energy this morning, to really go into communication with all our staff. As mentioned, it's around 1,000 people who will move to this new site, so we have to communicate very actively with the persons, because as also said this morning, the first people think, oh, they want to get rid of us. On the bottom left, you see the roadmap we created. So we have chosen a digital use case catalog of around 100 use cases and took out 67 use cases and put them into a vision, into a strategy map, and then tried to really implement a program where we go this step on the right from lean to digital to connected, predictive, and collaborative. And currently, we are in the range of connected, where we are currently working on. So this is how it looks like. Maybe you recognize the building again. So it has 3 floors, and we will have manufacturing floors on all 3 levels. And on the top, you see the digital backbone, which really goes from the supplier connection into our internal manufacturing and engineering departments. It goes to the customer. This is very important for us. So the systems are connected remotely to us, and we are doing predictive maintenance. So you have several wear parts in the systems, and then we offer the hospitals to change proactively their X-ray tubes. And all this information is given to our backbone. And at the end of the life cycle, we are very happy. We get all the instruments back, and then we can check if our predictions really been correct. And now I would like to show you some of the use cases we implement. So we are using this manufacturing information and intelligence, which I will come to later on. So bringing all information of the technology center together and illustrate it, and also perform data analytics on that. The digital tool landscape, very important topic to have one backbone, digital backbone where all documentation is done. So CAD, simulations, workforce planning, that you have one digital backbone for all this kind of applications. Smart maintenance is probably the most easy to explain. It's just connecting the machines and look if they are running correctly. Then smart logistics, what we heard, logistics planning, but also location of material. We have around 30,000 tools in our manufacturing, and you have to locate them. And around 600 machines which have to be connected. Then the manufacturing operation management, which is done by digital worker guidance and documentation, and the cash cow of the whole transformation. It's the workstream invisible quality. I will tell later on, because this workstream really takes all the advantages of the digital world and brings it to reduce cost. So how do we implement this now? Because it's a huge program, transferring 2 sites, building a new building, and bringing the people up. And now some more information about the individual work streams. So manufacturing information and intelligence means where is our data stored. On the right, you see really the site itself, so the manufacturing plant. All data is transferred to our internal data platform, very close to the manufacturing, that we get low latency. that we can perform real-time analytics. We offer then from the IT a REST service where all machines, all information is just buffered and going to the Snowflake database, which is very scalable if you want to perform high-power computational efforts. And of course, on the left, you see all the SHS from Siemens Healthineers IT platform where all the data from the field is coming in. As mentioned, so the medical images, for example, the reports, the machine data, it's coming from the left, and so we share the data through the whole organization to optimize our products. The digital tool landscape is, now I have to check if the pointer is going. Yes. So here you see the R&D. So in the R&D department, we have the product planning and the product engineering, and then it's going to the production here. And in this interface, it's very important to make this data transfer very reliable and fast. And therefore, we have here the digital product twin as shown before, where all the requirement engineering is done, the simulation, but also the 3D models, intelligent 3D models. They are distributed to our suppliers, and they can directly manufacture the material on their machines with the 3D models. And on top, you see the digital twin of the production. So this means the 3D factory with all the resource planning, the factory simulation, also here value stream simulation, then also simulate physics. So here you see a furnace. We have several furnaces glowing our material at around 1,700 degrees Celsius. We have to simulate these thermal processes, and this is done also in the backbone. And currently, we are in this phase 2, step 2. So R&D is nearly completely finished. Step 2 is now the transfer to SCM, where we are setting up the tools. And for smart maintenance, I think I can go quickly through that. So we connect our equipment to the data platform. We use digital maintenance to get all the information concerning failures from the machines, to get problems with the machines. Then if there has to be done a repair, it's also digitally assisted. And at the end, what you can also see here, the expert is going remotely to the production engineer who is really repairing the machine. Concerning logistics, what are we doing there? Of course, we use this advanced planning system. So if the order is coming from our customer, then this order is planned into our manufacturing through a SAP interface. And what we plan additionally is the autonomous mobile robots. Currently, we don't have the room for that in our current building, but in 2023, we will have enough space, and then we will start with the HEVs. The challenge is there to really coordinate the HEVs through all 3 floors, because it's 3 floors which are connected in the manufacturing line. And the clean room itself is unfortunately in the 3rd floor, but this was not, could not be done otherwise. And I mentioned it before, here you see the real-time location system for tracking material, products, and also tools. So around, as mentioned, 30,000 tools. You cannot handle this by hand. So you have to create geofences that you get an alert if the instrument or the tool is taken out from an area where it should be. Then for manufacturing operation management, we use our SAP backend. So here the orders are coming in from our customers. We are bringing this down to our MES system, in planning in detail the manufacturing, and then through an interface, it's called SAP Pico. It's going to the machines in the shop floor, planning and ramping up the machines, bringing them from standby to work. And what we get back through this interface is, of course, the energy monitoring, the OEE level, and all these kind of things you need to control your manufacturing. And this is the work stream I really like the most, because this is bringing our ROI back, the invisible quality. What does it mean? It means that we have a lot of sensors and a lot of algorithms controlling our manufacturing. This can be sensors we are adjusting here. Here it's an oil pipeline. We are adjusting here to check the cleanliness of the isolation oil. And here also small IoT sensors, which are mounted onto the products during the manufacturing. It's an X-ray tube here. You just bring the sensor on top, and the sensor is working all through the manufacturing. And we really achieved here a great success with this use case. At the end of every process, you are doing a testing, a final test normally, where your product has to show that it fulfills all customer requirements. We acquire all the parameters during the manufacturing. And what we trained here is we have an IA, it's productive, where our final test gets an IA score, and around 50% of the products can be taken out after 15% of test time, because we are sure that the product will be okay. So we really stop the final test process and say, no, this product does not have to test it any longer. We take it out, and then we can test the next one. And on the bottom, you see a vision from us. So we are trying to connect the internal data, the field data, how it's the system used in the field to optimize our products and to make the lifetime longer. This is done with the group in the US, where we have our AI experts and also the supercomputer I've shown before to do the optimization of all our processes. So how do we implement this? We set up a digital transformation program, it's called, on our side. So we created work streams, agile work streams. Currently we have 5. They consist of a development team, of a product owner, and a scrum master. We call him facilitator. And these 5 teams are doing their job in a 2-week sprint. And every 4 weeks, every team makes a small demonstration what they achieved. And then every 4 weeks, we also have a big demo, we call it, yeah. On the program level, we bring all the workstream members together. Everybody is free to join this meeting, so it's really a huge event where we demonstrate what's going on in the digitalization program, and the people can also give feedback. So what is okay, what is not so okay, and also their fears. Because here we have also the change management implemented. It's a comparable role as we had this morning, really bringing what we are doing to our people. And of course, the management also wants to have a look what we are doing, and this is shown on the right side. So every 8 weeks, we have to talk about budget, expenses, and milestones we are achieving. Yeah, so and then I'm at the end, so thank you very much. Here you see again some numbers. This will be the building in Forchheim. So here it's 6 floors, office buildings, and on the right it's 3 floors, manufacturing buildings. It's around 57,000 square meters of manufacturing site. So thank you very much. I would be very happy if you have any questions. And if you have any questions later, you can contact you, of course, via LinkedIn.
Impressive. Jens, from your side. Any questions out of the audience here locally?
So there's 2 questions from the digital audience.
Okay.
The first delegate says, looks like that you are very advanced here with a digital twin, also in production planning, combined with PLM and plant operations. How much is this implemented in day-to-day decision-taking, and who are the main users?
So it's implemented currently, I would say, around 50%. And the users are shop floor people. So we have the shop floor boards where all the material planning is shown. The engineering is doing their control. It's really going through the complete organization.
And another question from the digital audience. Are all of the topics and tools listed in the Siemens Health IT developed in-house, or are they provided by external suppliers or cloud services?
95% is done in-house.
Short answer, right?
Yeah.
Impressive. Okay. So if I'm looking to your slides, you have on one slide an IoT sensor. It looks like a little bit to a Raspberry Pi. Is that right?
Correct.
We are at Siemens, right? Raspberry Pi.
Yeah,
it's very interesting out of cultural reasons, and as I saw it, that you feel free to go creative new ways, right? To use, not in this case, per example, S7 or something like that, right?
Yeah.
Sure, it's very impressive. If you're looking, one question at the end from my side, of the way of Siemens, we heard something about wind, right? Then we get your information from health engineers, right? Somebody from Festo, Mr. Hoffmann, Professor Hoffmann, said to me sometimes, "Oh, Frank, it's 2 years ago. Frank, the world is on the way to go to be on the one side the Dingemacher in German, right? Dingemacher in German. And on the other side of the Atlantic, there are the Internetmacher. So Dingemacher, Internetmacher. You said you do your most important software issues inside, right? My question is, how do you feel out of your heart and out of facts that Siemens is on the way more to be absolutely excellent on the side of the Dingemacher or on the Internetmacher, because I looked first time to your supercomputer, right, in USA.
Yeah, I would say it's really the transformation currently to the Internetmacher.
Okay.
So we have a lot of stuff which are doing, but especially the demos we are doing with the whole team. So the transformation work stream I've shown, it's above 100 people working in there. And if other people come together, they now learn the advantages of the IT. And a lot of the people who have been Dingemacher in the past are now working with digital solutions. And this is really a transfer we see.
Okay. So, Jens, thanks so much to you.
Thank you.
For the bridge between brown and greenfield orientation.
Yes, okay.
Okay.
Yeah.
To him.
Thank you.